So here we go. This is one example using a computer-based model. Okay, you can study fluid dynamics using physical laws, express them in terms of hydrodynamic, non-hydrostatic models. This is what's shown here. Okay, just to illustrate or to play around with these. So what's done here is a situation where a fluid is set up consisting of a light fluid, a layer of light fluid above a layer of heavier fluid. Okay, and you have a density interface. And the density changes by 2 kilograms per cubic meter across this density. Okay, so you have a seafloor at some depth. Okay, and you have only the top layer moves horizontally at a speed of 1 meter per second. And initially, the bottom layer is at rest, no current. Okay, and there's also a little trick. You don't need any boundaries, horizontal boundaries. Both sides are actually connected. We call it a cyclic, the boundary. So whatever goes out on the right side comes in on the left side. Okay, so it's sort of a little trick to avoid any interaction with coastlines or stuff. And then you can just see what happens. Okay, and I just show you the simulation. If you want to learn about this art of modeling, I can give you links. I have lectures on ocean modeling. You know, I can also give you links to textbooks and stuff if you're fascinated by it. Okay? So initially, something like a video that I just show, or the animation that I show you on the next slide, is actually that motivated me to learn more about it. So this actually started my interest in my career as physical oceanographer. So all right, so let's have a look at the animation, at the simulation. You can see what happens. You look from the side, you see the development of waves. The waves start to break, create mixing. Okay, and they mix, and this is a simulation. It happens here in the interior of the fluid. These are internal waves. You could imagine that this is sort of the base of the surface mix layer, and you create the mixing here. Okay, so it explains the generation of surface and internal waves, mixing at the ocean interior, wave breaking. Well, there's some downsides here because you get only mixing, you don't get any. There's also mechanisms that facilitate actually type of an unmixing. Think about the sea surface. It actually never mixes with the atmosphere. You never get a transition zone. Anyway, so this is one mechanism of in principle how mixing is created in the ocean interior. Kelvin, Helmholtz, instability.